Hello, this is Chapter 3, question number 47. It says, normal is only approximate. ACT scores. Scores on the ACT test, it's a standardized test. A lot of students take it in high school. For the 2010 high school graduating class, had a mean of 21.0 and a standard deviation of 5.2. Let's go ahead and make a note of those key facts here. So the mean is 21.0, standard deviation 5.2. All right, let's keep reading. In all, 1,568,835 students took the test. Of these, 145,000 had scores higher than 28, and another 50,860 had scores exactly 28. ACT scores are always whole numbers, so you can't get like 28 and a half. You get either 28 or 29 or 30 or whatever. The exactly normal N 21.0 5.2. So remember this notation right here. The capital letter N means normal curve. Mean 21.0. Second number is standard deviation 5.2. Distribution can include any value, not just whole numbers. So right there, we've got a bit of a problem. If you looked at the actual histogram of the actual scores, it would look something like this. Everything is only whole numbers. So you can have, maybe someone scored 5. Some people scored 5. Some people scored 6. Some people scored 7, et cetera, et cetera, et cetera. However, if you look at a normal curve, then you can see here that uh, you could get a score of 5.5, 5.6, 5.7, any number at all could be on the normal curve. So right there, we know that we don't have a perfectly normal curve. All right. Uh, what more? There is no area exactly above 28 under the smooth normal curve. So ACT scores can only be approximately normal. To illustrate this fact, so part A, find the percent of 2010 ACT scores greater than 28, meaning of the actual ACT scores. So let's erase these here. We don't need these diagrams. They're just going to get in the way. All right. So the actual that's just an arithmetic problem there. So we had it says back here in the problem 145,000 had scores higher than 28. So that's 145,000 had scores higher than 28 out of the entire population of students who took the test. About 1.5 million. 1,568,835. Okay, so just do that division and you'll get your answer. I'll just use the little calculator that comes with the computer here. So that's 145,000 divided by 156,835 equals 0.0924 and round it off. How about round it off to 0.09? Okay, so it's about 9%. This is the approximately equal also. So about 9% of the students scored above 28. Okay, part B says another 50,800 scored exactly 28. So part B is the percent of 2010 ACT scores greater than or equal to 28. So that's going to be all the people who scored greater than 28 plus the 50,860 that scored exactly 28 divided by the 1,568,835. Okay, let's do this calculation here. So clear. So let's add here 145,000 plus 50,860 is 195,860. Divide that by 1,568,835, and that equals 0.1248. So about 12, let's say 12.125. So about 12.5%. These are approximate here. About 12.5%. So when you're dealing with whole numbers, it makes a big difference whether you include the score of 28 or not. Now, on a normal curve, now part C is an actual chapter 3 question. It says the percent of observations on a normal curve. So this is a theoretical question here. If we had a perfectly normal distribution greater than 28. So that's the old trick. You convert to z-scores, and then you look up on the table. So z is the particular score you're interested in minus the mean divided by standard deviation, which in this case is 28, minus the mean, which is 21, divided by standard deviation, which is, hold on a second here, 5.2. Okay, let's do that calculation here. 28, I don't need a calculator to tell me 28 minus 21, but well, what the heck. Equals 7. Okay, divide that by 5.2. Okay, 1.35 rounded off to 2 digits. 1.35. Okay, so let's take a quick look at a normal curve for this. 1.35, so 0 is in the middle, the standard normal curve. 1.35 is up there someplace. So I'm looking for this percentage, the score greater than 1.35. And let's go to the table. One of these has the table here. I think it's this one. Here we go. So find 1.3 here, and then 0.5 up there, and then see where they match up. 1.3. Here we go. 0.9115. Oops. Well, I'm trying to just get one part here. 0.9115. And that is the area that's to the left. 0.9115. So that is the area to the left. I need the area greater, so subtract that from 1. So 1 minus 0.9115, and that is 0.0885 if I did my math right. So that is the area according to a normal curve. Now notice that the percentage that got strictly greater than 28 on the ACT test was 9%. That's pretty close to what the normal curve tells us. If you include the 28, we get 12.5%, which is much higher than what the normal curve tells us. So that's an illustration where when you have whole numbers only, just going straight to a normal curve, even if your data is approximately normal, can make a difference on whether you include that particular whole number or not.